We are on the section 2.10. We are going to learn two more types of applications. Okay, so far before the exam 1, we have been learning the skills and tools about first derivative. And then we learn the second derivatives, okay? Then after that, we have been using those derivatives to decide how to maximize the profits or maximize the harvest size or even maximize tax revenue, right? Then we are going to learn two more applications. One is elasticity of demand. We see what it is. For your business class, I don't know you have learned this already or not, okay? So let's go through it, how we are going to use the elasticity of demand and how to calculate them. It's quite complicated, okay? Then let's talk about what kind of concepts behind it, okay? So we said there is something called farmer's paradox. It happens that abundant harvest bring a lower total revenue. How come? Then a poor harvest, right? You thought that you have poor harvest, then you have less revenue. And however, because it drives to a lower price, then you have abundance of harvest, but you have a lower price. Because it drives to a lower price with increased demand, right? You have lower price, then you have more demand, but the demand does not increase enough to compensate for the lower prices. So it ends up, you have what? Lower revenue for the whole thing. And you have lower total revenue. Okay? So then people start to think about it. I think it will be economists, right? So we have what? Revenue will be what? Your price times quantity sold, right? Very straightforward. Then when you set up a higher price, what do you think? The demand quantities would drop, right? People incline, not to buy it, right? So, but if you drop the price, then demand quantities will be up. All right. So, but some situation like this. So let's look at some examples. So if for the, we say we drop the price, then see what happened to the demands, right? So if we have a 1% price drop, then if we have a 2% demand quantities up, then under this condition, revenue turned out, and they did a study, revenue, it's up. However, if say you drop 1% of price, but your quantity, demand quantities, only has 0.5% up. Then they realize, oops, revenue actually dropped. Okay? So they calculate this way. Okay, they did a comparison. Then they did what? Okay, compare 2% to 1%, it's 2. Okay, this case, they compared, say, 0.5% divided by 1%, compare the quantities percentage with the price percentage. Okay, turned out it is half. Okay, so they are thinking, all right, this one is above 1, this one is half, below 1. So somebody, let's Google it, or you study in your business class, then so they find out, they call it what? Elasticity. How flexible the situation is as, prices and quantities fluctuate, all right? They say, okay, about elasticity of the demand, right? If demand high, okay, it sounds good. Demand is low, doesn't sound too good, right? So the elasticity of demand was what? Invented. So somebody figure out how to figure out that, right? To analyze such problems. So then they develop the formulas and see how it works out. And those type of thinking, right? The price elasticity of domain is important to firms because it helps them in pricing their products, right? If this theorem and this thinking works, right? And it will help them in pricing their products. A product with elastic demand is more what? If it's elastic, means what? More responsive to a change in price, right? So if the demand of quantity is elastic, that means it's flexible, responsive to the price change. Then you can decide how, you wanted to do it and what the price you can offer. So uses of price elasticity of domain in business decision making, they use that. Also, the knowledge of elasticity of demand is also helpful for the government in determining its policies. Before imposing statutory price control, right, on a product, the government must consider the elasticity of the demand for that product. So to stabilize the market, right, as well. So we are going to study all these concepts, then see what kind of formulas, right, people invented to solve such issues. Okay, so let's look on your page 59 in the middle for the formula. Then see how elasticity of demand, is developed. So it says elasticity of demand is a what? Measure of how demand demand reacts to the price change. Okay? It normalized. What does that mean? That means the particular prices and the quantities don't matter. They try to normalize it. And everything is treated what? A percentage change. Okay? See how it works out. The formula for elasticity of demand involves a derivative. This is a more higher thinking after we have what? Developed the calculus about 400, 500 years ago. Then the calculus, the method to calculate is using derivatives, first, second, and so on, right? To do things. Then they develop those ideas. So the way formula is written is this way. So regardless the price and the quantities, they use percentage, okay? Use percentage to compare. So they do this way. They say percentage change on what? In demand in comparison to the percentage change in price. Just like this. Okay? So when the situation is E is bigger than 1, then we call it what? Elastic. Demand is elastic. What does that mean? It means it's flexible, it's responsive to the price change. Okay? Demand is according to the price. All right. So they say, okay, if less than 1, it means what? Inelastic. It's less flexible, less responsive. Okay? It means what? The demand, okay, is not reacted to the price well enough, right? So we might as well increase the price because demand doesn't matter your price higher or lower, demand doesn't respond to the change of the price. Oh well, you might as well increase the price. This way you sell same demand, then you can make more what? Revenues. Is that right? That's the idea. Okay? So if E is 1, we say demand is what? Unitary. Okay, so that means, okay, it's not going up and down that way. Okay, it's not elastic nor inelastic. Okay, then see how does this unitary mean under circumstance. Okay, so that's the idea. Then demand function, we'll talk about functions a lot, right? So everything is by function. It's your model, right? Sometimes the models work well, sometimes they don't. So you make your call and your judgment, all right, by experience. So let's see. And they give a demand function quantity, right? Demand according to your P, right? The price. So it's written this way. So quantity according to P, that means what? Quantity from P to Q, right? From A to B, from X to Y, from P to Q. So we write it this way. Q is the function of the P. Instead of using F, we use D, means demand function. Okay, so your Q is what? Q is the quantities, right? That's the units sold, right? Then P is what? The price. If the price is P. So from P to Q, from A to B, right? Point A to point B. That's the demand function. And we wanted to talk about what? Elasticity of demand. That's what we are talking about first application, right? So it's this way. And elasticity of demand formula is written this way. So that's your E things, right? E, and according to the price. So it's written like this. Negative P dot times derivative, right? P or dP. Okay? Or we can write the absolute value P over Q over D prime P. Right? P is P. dP is what? Your quantity, right? D prime P. And we see why they wanted to do it this way. Okay? Let's find out. So if you have a difficulty understanding how it comes about, okay, that's fine as long as you can remember these formulas. Then understand which one P, what does P represent, and what is Q represented. Okay, then in different conditions for E, and what kind of impact it will be. Okay, so let's talk about how it is derived. Okay, so usually in math we call it proof. Okay, so we were talking about E is what? Is percentage of change in demand, right? Over percentage change in price, right? Then percentage change in demand means what? The rate of change, right? The rate of change is what? Change in demand, this one is the rate of change, the derivative, right? Then percentage means what? Divided by original. Is that right? So percentage is this one, right? And change in demand is D prime P, right? Same thing as a price. Percentage change in price is what? DP, derivative for the price, right? Change in price is your derivative of price. And over, okay, over what? The percentage means what? Compared to out of P, right? Then it becomes what? Percentage. Is that right? Then dP, take a derivative of P, that would be what? That would be 1 over P, right? D prime P over dP. Okay, complex fraction. So you do dp divided by 1p, right? Then you flip this, it's what? Times p over 1, right? D prime p, so dp, right? Then it becomes what? P times d prime p over dp, right? Then usually d prime p, what happened to d prime p? So d prime p is derivative of the price, right? Usually it's a downward sloping. The slope goes down, the price drop, right? So this one usually is negative. So we want to make the answer always positive. So we either use what? Absolute value, or we might write the negative d prime p, then put the negative there, so we make the answer becomes positive for us to calculate. Okay, so that's how elasticity of demand formula is that way. Okay, so you need to remember the formula, then see how we are going to apply it. So let's see what will happen if elasticity, okay, according to the price, can be bigger than 1, right? Can be what? Less than 1, can be what? Equals 1. Then, so when the elasticity bigger than 1, should we raise the price or drop the price to increase the revenue? Okay, so we say if this one, it means what? The quantities is responsive to the price change, right? Elastic. So it's a responsive, right? Quantities are responsive to the price change. So it means what? If you have a price cut, what will happen? What do you think? Will bring a larger income, right? Larger increase in demand, because it's responsive, right? Price cut, then you have more increase in demand, and what? And your revenue, total revenue, the whole idea is what? You want to increase your revenue, right? Will what? Will rise. So what do? You will what? Drop the price. May help. Right? Right? So if what happened if you raise the price? What do you think? If it's elastic, so you want to drop the price, may help. If raise the price, okay, so if raise the price, if raise the prices, right, you will decrease the revenue. Is that right? You will decrease the revenue, right? So if bigger than 1, what do you need to do? If you calculate with the derivatives, right? Then you find out the elasticity is bigger than 1. So what do you think you want to do? You want to raise the price or drop the price? You will what? Drop the price, right? Drop the price. That's the decision you want to make. So if less than 1, it means what? Inelastic, right? The demand is not so responsive, so it's inelastic. Then, what do you think? So if you cut the price, right? A price cut will bring what? Because it's not responsive, so we'll bring a what? Slightly, right? Slight, okay, increase. Instead of large, right? Increase in demand. Then what do you think? And the total revenue will what? Fall, right? We saw it previous farmer's paradox. We saw that. So what do you think? Because it's inelastic, right? So you cut the price, doesn't help you. So what do you think? So you will do what? A price, so you will increase the price, okay? Increase the price, then you still have a similar demand, right? So then price times the demand, that would be your total revenue, right? So you increase the price may help. Okay, so then in this case, if it's inelastic, what do you think? Okay, and if you raise the price, right? Then you will what? Increase your revenue. Is that right? Okay, so what we are saying is, if your E is what? Greater than 1, you want to drop the price or raise the price. That's the idea. Okay, so you want to what? Drop the price. That's what you need to remember. If elasticity is less than 1, what do you want it to do? To increase the price, to increase the revenue. Okay? If elasticity is 1 under this condition, that means this one is 1. What we are going to do? It will be what? Your maximum revenue. Okay? That will be maximum revenue. See? Okay? So, let's see why. Alright? We'll show you later on. So, elasticity is what? Interpretation. Okay? So, on the bottom of your page 59, it says interpretation of elasticity. If the price increase by 1%, Okay? And the demand will be what? The demand will increase by E%. Okay? That's describe and take a look at this a little bit later. Okay? See why it's that way. So we are saying the things you need to remember is the formula, right? Elasticity of demand. So when if it's elastic, right? So to increase the revenue, for the revenue, to increase the revenue, right? And so, what do you think? Should you raise the price or drop the price to increase the revenue? So you can drop the price to increase the revenue. Okay? If it's elastic, that means what? It doesn't matter for the price up and down, it doesn't impact the demands that much. So you might as well what? Increase, right? So you raise the prices to increase the revenue. That's what you need to remember. Okay? Then when it's unitary, then it probably is a maximum revenue at a time. So this is what? Maximum revenue. So that's what you need to remember. Then you use this function, the formula, to figure out your elasticity. Okay? So to make a decision. Let's take a look on page 60. An example there. So it says, finding elasticity of demand for commuter bus service. It says, a bus line estimates the demand function for its daily commuter tickets to be this function. Demand for the price from the price equals what? 81 minus P squared. So demand, D of P, is what? Your quantity, right? The amount of tickets you can sell. Then P would be your what? Price. That's what it's saying. And in thousands of tickets. So this is in thousands of tickets. Okay? And P is the price in dollars. So dollars is between $0 and $9. Find the elasticity of demand when the price is, one is $3, B is what? $6. Also give the interpretation of the meaning. So you look at the question and you were not sure. Okay, what does it mean? So what do? You can try to do some analysis. Okay, you just plug in the number and see what does it come out, then decide what kind of meaning can it possibly be. That's how it works, right? So you have price, you have quantity, that would be demand, right? In thousands. Then you figure out many is what? Your revenues. So what's the revenue? Revenue would be what? Your price times the ticket sold in thousands, right? So then price, do we know the price? Not yet. Then quantity is what? Your demand function depends on your price, right? That's that guy. Okay, because the quantity is the function of the P. So we say, okay, put a 0 here, 1, because 0 to 9, I will put a 3, 4, 5, 6, 7, 8, 9, right? I put a 0 here, would be 81,000 tickets. If you say write a free, you will have what? 81,000 customers. If you put a 1, that would be 80. Put a 2, we just write down all the numbers. 65, 56, 45, 32, 17, and 0. If you charge $9, nobody will ride your bus, right? Then you do the revenue. You just plug in ticket price times the quantity in thousands. So that would be 0. If you sell what? Oh yeah, because you sell $0, then you got a 0 income, right? So that would be 80. That would be 154, 216, 260, 280, 270, 224, 136, and 0. So if you list all this, you start to kind of figure out what's going on, right? So if you sell for $0, of course you have 0 income. If you sell $9, still 0 income because nobody will ride your bus. So you figure out what's the highest revenue would be here, right? If this is the model they studied and find out that's how it works. Then what do you think? Of course, you will sell what? $5 per ticket. Then you will have maximum demand. Then you have a maximum revenue at this time, right? So then the dollar you put in, see, you minus 1, minus what? 3, minus 5. So did you see the patterns? Minus 11. So the quantities dropped as price goes up, right? The demand dropped. So let's see. So demand function is this way, right? So if you calculate, okay, the first question is what? When the price is 3, right here, right? So what's your, E, elasticity? That's what we are practicing. Then see what does it mean, right? So at the price of $3, what do we have? We calculate our E3, okay? So E3, say it's this function, right? So P is -3 times D prime P. So what's your D prime? D prime P would be, take a derivative, that would be negative 2p. Right? So negative 2p, p is what? 3. So you times negative 2 and 3. Right? Negative 2p over d prime p. So d prime, actually p would be what? 3. P is 3. Right? So it will be negative 6. Negative 6. Right? Then what is your dp? dp is the demand, right? So p is 3. 3 squared 9, 81 minus 9 is what? So it's 81 minus 9, that would be what? 72. Oh, that's a ticket, right? The demand, right? So over the demand, 72. So that would be what? 18, 1/4, right? So if it's 1/4, according to our formula, and the E, elasticity, is what? Less than 1. Less than 1. So less than 1, what does it tell you? So it's inelastic, right? So it says a small price change up and down. We change just a small portion of in demand, right? So it means what? This one, E3, means what? E3 is 1/4. Okay, it means what? 1/4 divided by 1, right? Then 1/4 is the percentage change in what? This is a percentage change in the, we look at the previous page, we say, okay, percentage change in demand over percentage change in the price. That's how we count the E, right? That means this one is only, when you change 1% in price, only cost what? 1/4% change in demand, very small demand change, right? So it's inelastic. That means you might as well increase the price since it doesn't change the demand much. Then you get more revenue this way. Okay, that's what it's saying. So if you look at the next one, if at $6, so you plug in 6, right? So D prime 6 would be plug in here, right? Would be what? Negative 12. So that would be negative 6 times what? Negative 12, right? Over D prime P. So D prime P is, you plug in what? 6 to original D prime P, right? 636, 81 minus 36. So that will be 81 minus 36 is what? 45. Oh, that's this guy. $6, your demand would be what? 45. So the result would be 72 over 45. That would be 1.6. So 1.6 is what? Bigger than 1. Bigger than 1 means what? It's elastic. Right? Elastic means what? You want to increase the revenue by what? Drop the price. Because drop price, you will have more demand because it's elastic. Right? So if you look at this, okay, so if you look at this number, would be what? E6 would be what? 1.6 means what? 1.6% over 1%. Okay, then this one is changing in demand, this one is changing in price. So when you have a 1% of change in price, you will, have more demand. So you want to drop the price, here, so you have more demand and you have more revenue. So it's saying you have 1.6% change in demand, okay, when you have what? 1% change in price. So you have more change in demand. So you want to lower the price, so you have more demand, then you have more revenue. Right? That's what it's saying. So, to also give the interpretation of the meaning. Okay, so interpretation is this way. So, it says let's just write it out, for commuter tickets, right? At $66 piece, okay? So demand will fall 1.6% as price increase, right? Raised 1%, that's it, okay? Or you can say, or demand will increase 1.6% as as the price drop lower, right? We can say just lowered. Right? That's what it's saying. So, likewise for the $3. So what happened is we like to increase the price from $3 and drop the price from $6. Right? Does that tell you? And your analysis table tells you as well. Okay? So that's what we were talking about earlier. Say, if the price increased by 1%, the demand will decrease. It's opposite, right? Demand will decrease as this. So increase 1%, demand will decrease. But you drop the price, then the demand will increase. So if it's higher, right? Elasticity higher here, then greater than 1, then you will lower the price to make more revenues. Right? Okay? So, from the analysis, around $5 will maximize the revenue, right? We find out from the analysis. So, let's see. If we say, what happens E prime equals 1 if we do that? Okay, so we know, E of P. E of P is what? The equation is negative P formula, d prime P over dP, right? Then we have d prime P was what? Negative 2P, right? So if I do that, I plug in negative P times what? Negative 2P, right? dP is 81 minus P squared. So what do I have? I have 2P squared, 81 minus P squared, okay? If I make this one is 1, so what will happen? 2P over 81 minus P squared equals 1. Try to solve it. Then you multiply both sides by this. Let's see what will happen, right? So you have 2P squared equals 81 minus P squared. Then P squared plus on both sides, 3P squared equals 81 divided by 3. P squared is what? So it's 27P is about square root of 27, right? P is, it's about what? 5.19 something. So it's saying what? Around $5. If E is 1, around $5 you will have what? Maximum revenue. Is that right? So to find out the maximum revenue, so what do? You will do the E of P equals 1 will generate a maximum revenue. That's how we apply the elasticity of demand to maximize the revenue. So if it's a higher price, you drop the price, right? So if it's lower price, you raise the price to increase the revenue. From your business class, you might have this, right? From our calculation, we say price, that's your quantity, demand quantities, right? So you might have, so if your price from P2 drop to P1, when price, okay, it's low, then you have higher quantities, price is high. So when price is this, you have quantity this. When price is lower, you have higher demand. So your graph will look like that, okay? And from your business class, you might have this kind of situation, okay? So if you have a high price, then you drop to low price, right? So when you have a high price, your demand will be what? Low. Say Q1 will be here, Q1. So your price is lower, your demand will be higher, then demand will be Q2. So it will look like this. Okay? So that's your P1 supply, quantity, P2 quantity. So the change will be with what? From quantity 1 to quantity 2, right? So you drop the price, then you will have what? That will be your quantities changed, right? So if That's a regular, say, if this one is elastic, okay? And so for inelastic, okay, you might have a situation like this. So if your price from P1 drop to P2 same way, okay? So when you have P1, you might have a quantity of 1, Q1, right here. But when you drop so much price and you only increase a little bit quantity, slightly less than elastic one. So the shape may look like this instead, right? So what it's saying is your quantities changed only small portion, okay? So you might have seen this in your business class, right? So we are doing a demand function with this kind of graph. We say demand of, this is your Q, is function of P. So we do X and Y this way. Or you can think about this way as well. So for this section, we are talking about two applications. Okay, first one we just talked about was what? Elasticity of demand. That will help, you know, in business decision making, in pricing their products, right? You find the E value, then decide you want to, you know, raise the price or lower the price for products, right? Then another thing we are going to talk about is minimizing costs. So to minimize the inventory costs, also we call it what? Optimizing lot size. Let's see what we are talking about. So the concepts, you know, one way to look at it is during the 70s, Japanese car manufacturers, they thought about it just-in-time philosophy. Because if you know, for the manufacturer to keep the cars there, if you produce too many and at a time and have too many parts, then you need to have a place, have a lot to keep there, and that costs money, right? Cost in maintaining inventory, because that would need what? You have a storage cost, and you will have what? Then you have to also consider, if you don't order too many at one time, order many a lot, you know, order a lot at one time, then you have to order many times, then that will cost you for the reorder cost as well. So you have to have two considerations. Either you have big lot, it costs you to storage all those parts and cars, right? Then at the same time, you have to think about reorder cost. So then we are going to use the things we have learned, first derivative, second derivative, to minimize our inventory costs. Okay, so let's see some examples on your page 61. Here says, a furniture showroom expects to sell what? 250 sofas a year. Each sofa costs the store $300 to buy in, right? And there is a fixed charge of $500 per order. If you order one, pay $500. Order 10, you pay $500. Okay? If it costs $500 to store a sofa a year, and how large should each order be, and how often should orders be placed to minimize inventory cost? That's what we are talking about, how to minimize your inventory cost, right? Also optimizing the size, the area you have to rent, okay? So, two things we don't know, right? How large each order will be, because the total is 250. You can order 50 of them, then you have to order 5 times. Or you can order, what, 25 of them, then you have to order 10 times. Or you can order 250 of them one time, but you only order one time. But you have to have big space to keep them there, right? So that's a figure out. So what do? Usually we will do analysis first, right? As usual. So the store, okay, expect to sell how many a year? Expect to sell how many? 250 sofas per year, right? They know that for sure. Then the cost will be what? $300 to buy in per sofa, right? Then in $500 for place an order, right? Then, but if you order the sofa in, it will cost you what? For the storage for each sofa, right? So he wants to decide, the owner wants to decide how many orders per year, right? To be placed. So this one is undecided. You haven't decided yet. Okay? Then once you decide, if I want to order 5 times, then you know each time you will order 50, right? If you want to order 1 time, then you will order 250. So same thing, they are related to each other. How many sofas per order? Those are undecided as well, right? Then mainly we want to find out what's the total cost for doing one way or the other, right? So let's see. For each order, you can order how many? Let's just use good number. So you can order what? 250 of them. And how many orders do you need? You only need order 1 time, right? If you order 225 of them, you have to make 2 orders. If you order 50 each time, you have to make 5 orders. 25 of them, you will make what? 10 times. If you make 10 of them, you will order 25 times. Is that right? Right? Then, this one will be what? Number of what? Sofas per order, right? Then this one will be what? Number of orders per year. Is that right? Okay. So if I say, okay, that's how many I need, right? Then how many orders per year? That would be 250 divided by X, right? So 250 divided by 250, that would be one order. If you order 125 of them, 250 divided by 125, that would be 2 orders, right? So that's the thinking. We don't know how many, sofas per order. We just say X, right? Put the X there. Mainly is we want to find out what? The total cost, right? Including what? The storage cost and placing order, right? The cost for placing orders and the sofa's cost. So if you order 250 at one shot, so each one will be $300 times what? 250 of them. Is that right? Then each order will be cost you, okay, $500. Then how about the storage? 100 per sofa, right? So how much it cost you for 250? Right? It's not 250 times 100 because $100 each one, but at the beginning of the year you have 250. To the end of the year you sold them out, then you will have 0. So you average out. It's half of the size from the beginning. Okay, so you would do 250 divided by 2. Okay, so that would be your, this one we'll consider to be what? The average of sofas in storage, right? Then continue to sell those. Is that right? Okay, so if you do that, you can do 125. Okay, 125 each one would be what? $300, right? Times 125 each time you order so much. But you need to have what? Order fee, 500, right? So each time it will cost you so much to order, but you ordered how many times? Twice. So you times 2, right? Plus storage cost. Storage would be much less because half year you order 125, then you sold them out, right? Then next time you still have 125 next half year, then still average only 60 some sofas there, right? So that would be your storage cost. That's 100. Okay, same thing for 50, you do 5 times. So you have 300 of that dollars to, right, those are dollars, to 50 of them each time, plus, so each time plus $500, but how many times you do? Times 5. Okay, but the storage cost will be for average of 50 sofa. So it will be 100 times what? 50 divided by 2. Got idea? Not too bad, right? You start to have an idea how to do the analysis. right? So this one is 25 each time. So you order 25 of them, cost you $500 to place the order. Then you have 10 times to do that. Then you have what? Average 25 in store. Each one is $100. And 25 in store, average you only pay that many. If each time you order for 10, so 300 times 10 plus what? 500, right? But the 25 times you do that, but the storage is very cheap, 100 times only average 5 of them in store, right? So that's your analysis. So to set up the function for you to figure out, that's how you do. Because you see, your cost would be just like that, right? But instead, we have exact numbers of sofas, but we use what? X instead. Then we figure out the X, then we minimize the cost, right? Then we find our answer. That's how it works. Okay, so let's see. First one, we set up the function, right? So we set up, we have to have an unknown, say how many sofas per order, right? We say it's X. This one, we call it what? The lot size. Lot size. How big the lot will be to keep your inventory there, right? That's why we call it lot size for your X. Okay, then another thing we wanted to know is how many orders you will have per year. That will be total 250, you divide it by X. Okay, that's how you identify the things you need with one variable. We do that first. Then second one, we say, write your equation, right? The equation for our class is the what? Function, our model, according to the things we are doing, right? So it's for the cost. So you say total cost will be what? C of X equals what? That's what we are doing, right? Times something plus something. So how do we do? You will do what? Cost per order, right? That's the cost per order times what? Your cost per order is the whole thing, right? Then times what? Number of orders you will have, right? Number of orders, then plus storage cost. Is that right? That's the thinking, right? Then we write in X to show that. So cost per order would be what? Each sofa is $300, right? You times how many sofa you have. $300 times how many sofa you have. Then you plus $500 for the ordering, right? Then times number of order. Number of order is this, right? Times what? 250 over X. Is that right? Plus storage. Storage is $100 times how many in the inventory, how many you order. That's your X, right? Then your X divided by 2. Is that right? That's how you write your function. But you have to do analysis to be able to figure out your thing. right? So we simplify all this, it becomes 50x plus. You can do that yourself, right? That's x negative 1. Okay? So, we identify things we need with one variable, right? Then next one, write your equation. That means write your function, right? Next one is what? Solve it. Solve. Right? To solve it, we want to what? To minimize the cost. Then we need to use what? The new skills you have been learning, which are derivatives, right? First derivative and second derivative. So we will solve, we need to what? Find the minimum and check it, right? Finding the minimum, we need to find this one equals 0, right? Then find x. Then use C prime prime x to check it, right? So when we have a C prime is 0, C prime is what? You solve it, okay? C prime is, so your C prime x will be what? 50 minus you 125,000 x, drop one level, okay? Then this is what? X squared. Then you solve it, okay? 25 divided by 5, 25. So then you solve it, x is 50. You should know how to solve this one, right? If you don't, you need to call me or call tutors, okay? Then C prime prime x, you take a derivative for this, multiply this will be positive 250,000 x negative 3, right? That would be 250,000, right? Over x cubed. But we know x is what? Positive number. So this one is what? Greater than 0. That means when you have x is 50, then you solve at x is 50, then the C of x, right? C of x is a minimum. Minimum means what? You minimize the cost, right? So that will answer your question is, how large should each order be? You will order what? 50 sofas each time. Then how many orders do you need? You need 5 orders, right? So you will write your conclusion, right? You will say having what? 50 of them, right? Per order, right? That will minimize the cost. Right? So it will require how many times? 250 divided by, right? 5 times. 5 orders per year. Is that right? Not too bad, right? Not at all. So this one is more straightforward than, you know, other applications we have, right? Okay, let's look another example on your page 62. How to minimize costs, right? Minimizing your inventory costs and optimizing your lot size. Same thing. So it says a publisher estimates the annual demand for a book to be 4,000 copies. Okay? Each book costs $8 to print, and setup costs are $1,000 for each printing. If storage costs are $2 per book per year, find out how many books should be printed per run and how many printing should be needed if costs are to be minimized. So we know how many copies we want. 4,000 copies total, right? Just like previous example, you need 250 sofas, right? Then cost to produce, your expense would be what? $8 per book, right? And $1,000 per setup, right? And storage fee is what? $2 per book per year. Right? So that would be your cost. So the idea is how many runs per year, okay? How many copies per run? That was the question, right? So we want to figure out how many runs per year, right? Then how many copies per run. If you know how many runs per year, then you know how many copies per run. Or you know how many, copies you want to run each time, then you can decide how many times you are going to run it. So both are undecided. Right? So we need to write equations for the cost, right? So how do we do? Of course, we will do the analysis, right? Then we figure out. So let's see. For each order, right? And how many copies? So we say how many copies per order, right? You can make 4,000 copies. That's you only need to do once. If 2,000 copies, if 1,000 copies, things like that, right? So how many runs do you need and set up? Okay, so set up, you need to do it one time, you need to do it twice, you need to do 4 times, right? Then the cost would be all those things. So if 4,000 copies, each one is $8, so it would be $8 times 4,000 copies plus setup a fee, right? Then you just do it one time. Then plus your storage cost. Storage cost is what? $2 per book for 4,000 books, half of it for the average, right? See the patterns now? Same thing as your previous sofa things, right? So this one would be $8, but 2,000 copies plus $1,000 setup, but you run it twice a year, plus $2 for keeping the book storage fee, but half of the storage, right? 2,000 book average, right? Each time, say half a year, you only have what, 1,000 books average. For 1,000 book per run, so you time 1,000, then plus $1,000, then how many times? 4 times. So plus storage, each book is $2 for 1,000 books, then average half of it. Got it? So what's our X? How many, things per order? So your X will be what? Your number of copies per order, right? Then how many setup you need? So how many orders per year? Number of orders per year will be what? Total 4,000, right? Depending on how many you order, then you divide it by X. Then that's how many times you need to order, right? So first, you set up, identifies you need with one variable, right? X. Then next one, write your equation. Then write your function, right? So write your function. So it's the cost. What's your cost? That's your cost, right? So that would be what? A times how many per year? That's your, this one, that's your X plus $1,000, right? Times how many orders? So that would be that times 4,000 over X, right? So let me just write it down first so it's more clear to you. So your production cost, right, would be what? Costs per run, right? Cost per run times how many runs per year, right? Plus what? Your storage cost. Is that right? Okay, so cost per run would be this guy. That would be $8 times what? The X, right? Plus $1,000, then times the run would be what? This guy, 4,000 over X, plus storage cost, that would be $2 times, right? Half of the order, X over 2. Is that right? So we spread it out, multiply them. That would be this guy. Plus 4,000, 0, change that to X -1. Right? So first you set up things you need. Second one, write your equation, which is cost function. Then we will solve it, right? We solve by what? Use first derivative to decide minimum or maximum. Then use a second derivative to verify it, which one is that, right? So we will solve by finding what? Find the minimum and check, right? So your C prime X is 0. C prime X is what? You take a derivative. So I'm just checking the number, make sure I multiply correctly. So AX times X should be 8 somewhere, right? Oh, 8 times this, 32,000, X cancel, that's that, right? And 1,000 times this is this. Where is that X from? Oh, here. Okay, I'm just double checking the calculations. So your C prime X is what? 1 plus this guy, right? Multiply, actually it's a minus 4,000, 4 million, X negative 2, right? Then you solve this, then C prime X is 0, right? So this one is 0 equals what? This guy. Then you solve for, that's negative 2. So your X is what? Square root of 4 million. Okay? So that would be what? 2,000. Okay? Then how do you know it's a minimum or maximum? So you need to do C prime X. Take the derivative of this would be what? Negative 2 times that would be 8,000 million. X to the negative 3, right? So it's the same thing is what? A million over X cubed, because X is what? Number of copies per order, so it's positive. So this one is 0. So it means what? It means C prime 2,000 is the minimum, right? So not the C prime is a C 2,000 is the minimum, because C, I should write it this way. That's what I was thinking. Greater than 0, that means this one cost at X 2,000 copies per order. So that will be your minimum cost. That's what it's saying, right? So you can write down the conclusion. So usually you set up first with your X with one variable. Then second one, write your equation as cost function or your profit function, right? Then third step, just like our algebra class 154A, we did this. And third step, we say solve the equation. This case, you find the minimum and check, right? By the new skills you have learned, first derivative and second derivative. Okay, then we draw a conclusion. We already did, right? Let's just write it out. So we say to minimize, that's what we are doing, right? The production cost, the publisher, we do what? Should print how many per run? Print 2,000, that's your X, right? 2,000 copies per run, right? And with what? How many runs per year? 2 runs and 2 printing, either way. 2 printing per year. That will minimize the costs, right? Are we okay? Understandable? Sure. Manageable. So that would be on page 62, which covers our section 210. So before exam 1, we were learning all the skills and tools doing the derivative, right? Then after that, we have been practicing using those skills, also second derivatives, to do what? Maximize the profit or minimize the cost, right? And we also did what? Tax revenue and other things as well. So that will give you a general idea how to use what? The new skills called derivatives to apply your problems. Okay?